Hey guys, welcome to another video on linear equations and relationships. This will be actually two videos. I'm going to do one video on substitution and one video on elimination. So in the last video we talked about if you have two simultaneous equations, so you've got 2x plus 4y is equal to 12, and you've got 3x minus y is equal to 4 or something like that. You could graph both those equations with your CAS, and that point there, that coordinate point x, y, would be the solution to both of those equations. I'm now going to talk about how to do it algebraically. So what I mean by that is, without a graph, just using some algebra, how would you work out that those two values there, x and y? And so after I've been through both methods, you'll need to copy down some notes for each. I would just use the textbook examples and then do that in your own words, and then finish exercise 3J. Okay, so substitution. Substitution involves substituting the value of one or substituting one equation into another. Okay, so for this first example, solve for C and S, I'm going to call this equation 1 and I'm going to call that equation 2. Okay, and with substitution you want a value, or you want an expression for one variable. So what I mean by that is I either want C by itself or S by itself. So what I'm going to do is, if I take away S from this side and I take away S from that side, because I want to keep it balanced, plus S and minus S cancels out, and this side here becomes 6 minus S. So I could say this equation 1 is that C is equal to 6 minus S. Okay, I'm going to call that equation 3. So now that I've got this C is equals to, I know that anytime I see a C in an equation, I can change it into 6 minus S. Okay, so what I'm going to do is sub 3 into 2, sub 3 into 2. So I'm going to place this equation, I'm going to change this C value here into 6 minus S. Okay, so two lots of 6 minus S. All I've done is I've changed the C into what I've into this 6 minus S plus 3S is equal to 14. Okay, so we need to do a little bit more algebra. I expand this. Okay, so 2 times 6 is 12. 2 times S is minus 2S plus 3S is equal to 14. Okay, collect my like terms. So minus 2S plus 3S is going to give me just positive 1S. So 12 plus S is equal to 14. And now I just need to solve for S. So I need to get rid of that 12. So I'm going to do the opposite. Plus 12, I'm going to minus 12 to both sides. And I'm going to be left with S is equal to 2. Okay, so what I've done there is I've found the value for S. Okay, now I need to find the value for C. I've found S. I've got to find the other value that's unknown, C. So what I do is, if S is equal to 2, sub into equation number 1. Okay, so I'm going to put this value for S is equal to 2 back into the original equation. Okay, because I've got to find C. So C plus 2 is equal to 6, okay, because that's me substituting S, and now I just need to solve it. So minus 2 from this side, minus 2 from this side, C is equal to 4. Okay, so those two values of 2 and 4 will be true for both of those equations, 1 and 2. Okay, alright. So now let's look at this second equation. I'm going to call that 1 and I'm going to call this 2 as my vacuum computer really revs up. And you can see I've got y is equal to for both of them. So what I can do is I can just say that 1 is equal to 2. Okay, I can equate them, because if I know y is equal to both those things, I can do this. So I can say x plus 5 is equal to negative 3x plus 9, and I can solve for y. Okay, so I want to get all my variables on one side, so I want to get rid of this negative 3x. I'm going to plus 3x to this side and plus 3x to this side. That will cancel out, and this becomes 4x plus 5. That's equal to 9. I want to get rid of this 5, so I'm going to minus 5 to this side and minus 5 to this side. 4x is equal to 4, and I'm going to divide both sides by 4 to get x is equal to 1. Okay, once I've got x is equal to 1, I can sub x is equal to 1 into equation number 1, and I know that y is equal to 1 plus 5 means y is equal to 6. Okay, so that's me solving two equations with substitution.